Hi everyone. So the previous video, we could just do one page in the entire video. And that is because we're learning something very new, how to solve equations and inequalities involving the absolute value functions. And not even one page actually. I was at the end of this page 10, okay, towards the end of the video 13. I'm going to continue now here. And the problem we were discussing was to solve this, absolute value of f of x is greater than absolute value of g of x graphically, right? And here are the graphs of f and g. I have highlighted them in blue and purple for clarity, okay, f and g. And just to a quick, background, previously, we have solved that equation, absolute value of f of x equals absolute value of g of x. Let me highlight over here. We solved that equation in the previous problem, right? And we found that the points of intersection are -1 and -8 over 3. Mean the x values, okay? For the points of intersection, the x values are -1 and -1, 8 over 3. That means there are 2 points in the graph where these two functions will intersect. Okay, I want you to keep that in connect with that later when you have the solution. These are the points where the two functions are equal at x equals -1 and at x equals -8 over 3. Okay, and what is the connection of these points for the next inequality that we are solving, right? Now, coming down here, the answer itself is quite simple. Okay, so let me just build up some important background here. Firstly, both graphs that you see here, left and right, it's the same graph, but they are given two different points. Okay, the points of intersection. Here x is -8 over 3, 2.6667 is 8 over 3, right? And y is 6.6667, which will be 20 over 3. Okay, in exact terms. And here we have -1 and 5. Okay, now where is f of x greater than g of x? If you look at the graph, there is one region clearly. Okay, and that region is this, what I highlighted just now, between in that V shape, the part in between which is cut off is where f is greater than g. Think about that. The purple one is f. So if you are in that region between these two V shapes, if you are in this region, your f, the purple line, is greater than the v values, right? Remember, we have to compare the y values. Okay, so if I'm here, let's say, if I'm at that point, that is my value of f of x, whereas the corresponding value of g of x is somewhere here, vertically down. So that is where f is greater than g. But the moment you cross that 2 points, okay, if I come, these are my boundaries, the ones that I highlighted in blue just now. And if I move beyond that, if I were to go, let's say to, sorry, actually I didn't mark the boundary correctly. Here, this and this, these are my boundary, right? The moment I cross that, let's say if I'm here, now G is greater than the corresponding value of F, right? And that happens on both sides. Okay, now G is going to go up very quickly and F is growing slowly on both the sides. Okay, so beyond that, either on the left or right, G is greater than F. All right. So clearly the answer is simple. The answer is, if I have to find out the solution, which is the x values, I have to see what are the coordinates of this point and this point here. And our answer is also already there because we have the left point -8 over 3 here and the other point is -1. The x value here is -1 is there, right? Therefore, I can now say f of x is greater than absolute value of f of x is greater than absolute value of g of x on what interval? Minus 8 over 3 to minus 1. Okay. All right. Here is your homework. I hope you have been continuing to do your homework. It will be due soon. Okay. I'll be publishing the uh, announcement on Blackboard. Let us move on. We'll go to the next page now. We are in page 10. We need to go to page 11 now. Okay. Now, this is the next lesson, lesson 2.5. And what are we studying here? Piecewise defined functions. Okay. And some once in a while, this discussion has come up before also. And in fact, we have already seen the absolute value function that we were studying before this is an example of piecewise defined function, right? How do we define the absolute value function? We say it is f of x if f of x is equal or greater than 0. And we say it is minus f of x if f of x is less than 0, right? That means we are, um, creating this rule, two rules basically. The word rule, okay? My in-person students know, I don't know if I have mentioned this enough in my online classes. The word rule and the word function. These two words, there is sometimes they are used synonymously, but there is a subtle difference, okay? The subtle difference is there is only one function. When you are talking about a function, the function is only one, but the rules can be many. Okay. So in a piecewise function, what I was talking about the absolute value just now, the function is same, but it has different rules for different parts of the domain, right? Either it is x or it is minus x. So the rules are different, whereas the function is the same. Okay. So that is the definition, that is the understanding of piecewise defined function. A single function with multiple rules. And multiple rules where? For different parts of the domain. So you cannot have multiple rules for the same value. Then it is not a function. All right. Then it will fail the vertical line test, or whatever, right? The same image, element in the domain cannot have two different images. So the two rules will not apply to the same point. The rules, there are multiple rules, but they will apply to different parts of the domain. So basically you take the domain, you slice it, and for different parts, you have different rule. Overall, there is only one function. Okay. I think that is a sufficient explanation on that. Let us look at an example. This function f of x here, when is x is less than 3, you have a formula x minus 2. So that would be the straight line y equals x minus 2 for that region, And when x is equal or greater than 3, you have a different rule, another straight line. So basically, it is the same function, but it is going to have two different lines on two different parts, less than 3 and greater than 3, right? Will they meet at a point? We don't know. Let's see. Okay. What is f of minus 5? You have to check whether minus 5 is greater than 3 or less than 3. Obviously, minus 5 is less than 3. So your rule is going to be x minus 2. Okay. And what is f of minus 1? Minus 1 is again less than 3. So minus 1 minus 2, which will be minus 3. F of 0, again less than 3. So 0 minus 2, minus 2. Whereas if you go to f of 3, now f of 3 is equal to 3. So in general, you can write 3 is equal or greater than 3. that is true, okay, because it is equal to 3, so when we say equal or greater, it is still true. Therefore, what's going to happen here is the second rule. Okay, so that is how the function would be. I'm not sure why didn't they ask for like a value which is greater than 3. So let me just add one value here. Suppose if I were to ask you to evaluate f of 5, right? Then because 5 is greater than 3, 5 is equal or greater than 3 is true. So you will apply the second rule, which will be 5 minus 5, 0. Like that. Okay. So basically, you have to choose which rule to apply depending on the input value. And you have to see sometimes there are more than two rules. Okay. So you have to see that particular X value in which of the parts does it belong to, and then apply the same rule. Okay. Corresponding rule. Okay. Let's do this exercise together. Graph the following function. 2x minus 1 if x is equal or less than 1. Okay. So a simple way to do this graphing would be just find 2 points on each of them, because they are all either constants or straight lines, so it should be easy to graph. If it is some other function, not a straight line, if you have x square or x cube, if you want more confidence, you can take like 3 4 points, for that particular region, and then draw freehand sketch. Okay. In this case, we just need 2 points at the most. Actually, for the second rule, we will not need. I'll explain. 2x minus 1. Okay, and that is for x equal or less than minus 1, right? So I'll take, let's say, two values, like, I can take minus 3 maybe. So it will be minus 6 minus 1 minus 7. Make sure you understand that calculation, okay? And when I take, now the next point I can take minus 1 itself, because x is equal or less than minus 1. So at minus 1 also we have the same rule. Minus 2 minus 1 will be minus 3. Let me sketch that immediately. Okay, at minus 3, oh, okay, 1, 2, 3, 4, 5, 6, 7, approximately here. Okay, it is there. And at minus 1, it is at minus 3. And so your graph would look like that. Okay. And I'm drawing a solid circle there at minus 1, minus 3, because it is equal or less than minus 1. And I stop there. See, that is important. Don't continue that line, because after minus 1, to the right of minus 1, your rule is different, right? What is it? It is 4, constant 4. So, which means, and not exactly at minus 1. At, let me do it more visibly. Exactly at minus 1, you have to draw a hole. Okay. I want to just circle that. Yeah. Okay. At minus 1, you draw a hole because it's minus 1 less than x. But at 3, when you reach 3, you can make it solid. Constant, right? Y equals 4. Then the graph is minus x from 3 onwards. Okay. Now, what is the equation y equals minus x? Okay. So in between here, I'll just write the equation y equal to 4. All right. And after that, it is y equals minus x. For x greater than 3, it is minus x. So which means if you take 4, the y value is minus 4. If you take 5, the y value is minus 5, right? That's what it means. And you can plot that to get an idea. 4 minus 4, 5 minus 5. That would be your line. But let me use a different color. 4 minus 4, 5 minus 5 here. Okay. But I have to continue that only till here. Like that. X greater than 3, right? So there is a hole there. Okay, that would be the graph for the given. Okay, once that sinks in, let's do the reverse process. There is a graph given, you write what the function is, give the definition, the piecewise definition. Although you have not done it before, still, if you want to give it a try, pause the video and give it a try. But if you just want to continue watching, do that. Okay, and my answer would be this. Y equals f of x equals two things. I'm going to read this coordinate here as 2. Okay, this is 1, that's 2. And here it's 1, 2, 3. Okay, so that line is y equal to 3. And here is 1, 2, 3, 4. That is y equals minus 4. Okay, so my rule is going to be this. F of x is 3. Now, I don't know, you have to take one of the points as included. So I'm going to include the 3 with the one where there is a cross given there. Okay, 3 if x is equal or less than 2. Please observe this very carefully. Okay, the x value is on the x-axis, of course, the horizontal axis 2 until x is equal to 2, right, or less than 2. The value of y, the output is 3. Similarly, it's minus 4 if x is greater than 2. Okay. All right. Now you can have some confidence and try to do it for the next function. And the horizontal line part, I hope you can write easily. For the vertical, for the dotted line, I'll tell you. Um, if you can already, please go ahead. Otherwise, I'll give you a trick. But then I want you to pause the video and try to solve it. Okay. For the scale, take this as 1, 2, 1, 2, 3 like that. I'm just like being simple here. Okay. And then what you do is for the dotted line here, which is oblique, take the coordinates. This is 1 comma 1. And it looks to me that when you are at 2, it is at 2, right? Another point on the graph. Okay. So based on this 2 points, you can get the equation of that line, right? Then you can define the piecewise function. Pause the video, do it, and then check your answer here. Your answer should have been f of x equals 2 for x less than 1, because there is a hole there, okay, on the horizontal line, and x for x equal or greater than 1. And why do I say x? Because the equation of that line is y equals x. If you ask me, oh, it's obvious, 1, 1, 2, 2, right? So it has to be y equals x. You can also find the slope and then get the equation, but you'll get y equals x. Okay, let's do one more. And for your reference, the functions that you see here, the curves that you're seeing, those are obviously transformations of the square root function. Okay, so you know how to write the equation, of a square root function which has been shifted, right? Using that knowledge from the previous lessons, write the solution here. Pause the video, write your solution, and check with me. The answer should be Okay. On the left side, I have a coordinate which is -3 comma -4. So my equation is going to be under root x plus 3 minus 4 if x is equal or less than -3. The solid dot is there. Okay. Why is that equation particularly that? I'll not explain now. I think we have done enough of that in the previous videos. If you are still confused, please watch those videos or contact me, meet me. We can discuss. Between the 2 points there, the value of f of x is 1, 2, 3. So it is 3 if 3 is less than x. So you have to write two-sided inequality. Okay, so be careful there. 3 or -3. -3 is less than x, equal or less than 2. Field circle on 2, right? So equal or less than 2 there. And finally, the other coordinate here is 2 comma 0, where that square root function begins. And by the way, there is no vertical stretching here. Okay, if anybody was wondering, if you look at this point and this point here, it tells you that starting from your vertex for 1 unit left or right, you are going 1 unit up, right? So and that is what happens with the square root function. 1 comma 1, right? And the square root of 1 is 1. So there is no change in the scale here. There is no stretching or shrinking. All right. Okay. And there what happens? If you plug in 2, so clearly that is x minus 2. That's all. If nothing on y because it's 0. Okay. X is greater than 2. That would be your answer. Okay. Moving on to the next page. Okay. You're asked to graph this function. Okay. Sorry, I have to take a call. I'll pause the video. Okay. One thing about this function is you look at the domain. Okay, the way it is defined, just notice that even before you start graphing it, it is not going from infinity to infinity. Okay, it is between -2 and 3. So this is a function with a finite interval. The domain is a finite interval. Okay, just keep that in mind. Okay, so it is half x between -2 and 0. And there are two ways to draw these graphs. Okay, again, because these are straight lines, and if you want to directly plot the graph of a straight line, you can go ahead and do that, like using the concept of the slope. Okay, or you just want to regularly plug in the values of x and get 2 points and then join them. That is also fine. Okay, and because I did joining 2 points in the previous previous page, I want to show how to do this just by looking at the slope in this video. Okay, sorry, in this page, not this video. All right. Half x, right? The slope is half x. So what does a line which has half slope look like? If you go 2 units on x-axis, you should go 1 unit on y-axis, right? Half, 1 over 2, rise over run. And that is between -2 and 0. Okay. And a line which does not have like some common like sense knowledge here. Okay. If it doesn't have anything extra, that is 0. So those kind of lines will pass through the origin, right? So I can very confidently now draw the graph. It will be here. And if you go 1 unit down, you should go 2 units to the left. There. Both solid actually. because they're equal or less than, equal or less than. So from -2 to 0, it will be that. Okay. And then from 0 to 1, it is -2x plus 2. Now, -2x plus 2 is a graph whose slope is -2 and y-intercept is 2, right? So clearly, I can start here. Y-intercept is 2 and also x value is 0 here, so it's exactly there. And then what is the equation whose slope is -2? If you go 2 units, if you go 1 unit right, you should go 2 units down. Okay, that is -2x, right? So 1 unit right, 2 units down will bring you here. That is the graph whose slope will be -2x plus 2. Okay, and join that. Open and closed, based on the given equation. And from 1 to 3, it is equal to -1. So equal to -1 here, all the way till x equal to 3. That will be the graph. Okay. So you can fill in the points and do it here. I'll leave that to you, but your end result should be the one that I drew here. Okay, I have a few more minutes, so let's try to do one more problem. Okay, there's only one problem on the right side here. Identify the piecewise function. So when this identify, basically they're asking you to write the equation. Let's write the equation, Okay, I think we should have enough practice by now, so I'm going to go ahead and write. Please pause the video and do it. Okay. On the left side, I have root x, but that's reflected, right? Y value is negative. Okay. So how does one write the equation of that? That's reflection on y-axis, by the way. So minus under root minus x, I think. Yes. Okay. Now, if anybody is wondering how did I get that? Okay. For x equal or less than 0. All right. Now, if you're wondering how did I get that, this is my y equals root x. Okay. Then if you reflect it on the x-axis, we make it minus root x, right? Now you're reflecting that on the y-axis. So it will be minus of root minus x. Okay. All right. And then between 0 and 2, what is happening? The slope here is 3 and 2. So the slope is 3 over 2, rise over run. Both are positive, right and up. So the slope is 3 over 2 x, and the y-intercept is -3. Straight line, right? For where 0 less than x equal or less than 2. And then it is sorry, I should have made this longer. After that, it is constant, and the constant value is 4 for x greater than 2. Okay. If any part of this was not clear, think about it, ruminate over it, and reach out for questions. Okay. And there is a hint given here about a problem number 53, which I will ignore for now. Let us go to page number 13. Okay, I have around about 4 minutes left, and this page is going to be about a different topic. Okay, so I'll pause the video here. I'll do the next one in the next video. Thank you all.